paper in the symposium is Psychology and Epistemology of UFO Interpretations by Dr. Douglas Sykes-Williams, Chairman, Department of Psychology of Rice University.
I'm like a babe in the wood in this subject. I haven't been to Congress with it, or the Houses of Parliament for that matter. I haven't done any research. I don't have quarrels with anybody. I don't have rival actions with anybody. I feel rather changing my analogy like a virgin on her wedding night, but I better not say too much that we have a psychiatrist sitting down there, and hoping to say that later. I am interested in the philosophy of science, and essentially, I suppose, my contribution is around the theme. I've been struck with the somewhat, not exactly illogic, but lack of careful logic used in the interpretations given to reports of these curious objects. My theme is that distinctions must be kept between description, definition, and explanation. Failure to keep these distinctions often ends up in lack of clarity in discussing these reports, and often to logical mistakes. I propose to enumerate 4 stages, I think, through which inquiry has to follow, and to comment in passing on attempts made so far. Stage 1. Reports of curious, aerial, for the most part, phenomena are generated. This is the starting point, and here already we meet the first difficulty. Our primary descriptive term in the title of this symposium has met logical complaints from people of quite differing interpretations, from Hynek, Dr. Page, Baker, Dr. Menzel, and Dr. Valiant. Each of the 3 words runs into trouble. Unidentified because it embraces too much, flying because it suggests something mechanistic. We don't talk of a cloud flying except in poetry, bad poetry at that. Objects because it already presumes a conclusion. Smuggled into this term is already an assumption masquerading as a description, the term objects. The error is compounded when the other term, flying saucers, is regarded as synonymous with UFOs, as now we have an explanation masquerading as a description. However, it does look we're stuck with these terms, UFOs, and although something like anomalous observational phenomena, Dr. Baker's proposal, is logically preferable, we'd better go on using UFOs, remembering that the usage should not commit us to any interpretation. Stage 2. The reports now undergo differentiation. Investigators, experts, astronomers, meteorologists, and so on, of various kinds, have managed to eliminate the unidentifiableness of many reports, indeed the majority, and trace them to quite identifiable and understood phenomena. Nevertheless, there is left a residue of still puzzling phenomena. It is at this second stage where controversy really begins. What appears to be an insignificant and unrelated residue to one viewpoint is, from an opposing viewpoint, both significant and related. Whereas the first group may dismiss the residue, I think he's gone, but Dr. Hartman thinks this, as something akin to error variance, the second group accepts the residue as signal, or at least, being a little more cautious, are committed to the viewpoint that it could be signal, for which further investigation is necessary. Such further investigation brings us to the next stage, but there exists a problem which impedes easy transition. This is the problem of populations of reports. It becomes very quickly to the student of the subject that different authors are often alluding to different samples, and it is by no means obvious, anyhow to an outsider, how the different samples are related. It would seem that 3 populations can be organized, and I call them population A, B, C. Population A, those reports which are explained by reference to known phenomena, and which our questioning second group is not prepared to defend as still requiring investigation. In other words, everybody agrees that report X is that of a meteor or satellite or something, so let's eliminate it from a residue. There's no quarrel here, no argument. Population B, those reports which are explained by the first group as exemplars of known phenomena, but which explanation meets disagreement from the second group. There is valid and real controversy here. There's a whale of a one between Menzel and McDonald, for example, on this. But note that at this stage too, we need not necessarily have a conflict of 2 hypotheses, 2 kinds of explanations. Someone may disagree with a report Z as constituting ball lightning without being committed to an explanation in terms of extraterrestrial vehicles. The controversy is over whether one should leave report Z in the residue of still needing investigation or not. The reverse of this situation can be noted in the Condon report. Rejection of a photograph of a UFO as constituting evidence of an extraterrestrial vehicle does not permit the rejector to an explanation in terms of known phenomena. Dr. Hartman makes this point when he makes that remark in the Condon report. Population C. Those reports which both groups agree with as being unidentifiable and unexplainable in terms of known phenomena. Presumably all the unidentified in the Air Force files belong to this population, if they're not destroyed, as well as the explainables in the Condon report. All three populations are defined in terms of having been examined and evaluated. It becomes clear that there are many reports which have not been introduced to the scientific forum at all, and which therefore await assignment. It is necessary to make what may otherwise seem a very trite point about population grouping, because otherwise we're not ever certain whether we're talking about the same thing. It's worthwhile noting that the Condon report essentially terminates at stage 2. The scientific filtering there still left anything from 10 to 15, maybe 20% reports unexplained. Apparent reluctance of the report to proceed further is a decision to test the hypothesis. It seems to me that they made the decision, I should say, to test the hypothesis of extraterrestrial intelligence on the basis of the totality of their reports. A consequence of this approach is to present equivocal conclusions when unexplained instances are confronted. Thus, one of my predecessors in the symposium, Dr. Hartman, has this to say regarding photographic cases. Quote, the present data are compatible with, but do not establish, the hypothesis that, 1, the entire UFO phenomena is a product of misidentification, poor reporting, and fabrication, or 2, a very small part of the UFO phenomena involves extraordinary events, unquote. Again, in another part of the Condon report, with case number 14, the first sighting, quote, there is no reason to doubt the credibility of the sighting. However, the question of what was seen remains unresolved, unquote. Or again with case number 17, quote, investigation revealed neither the natural explanation to account for sighting, nor sufficient evidence to sustain an unconventional hypothesis, unquote. It would seem that the Condon investigators had difficulty in distinguishing A, phenomena of a certain kind that are unexplained, from B, phenomena that could be attributed to extraterrestrial intelligence. As the only hypothetical properties of the latter appear to be that which is reported as the former, the hypothesis of ETI, formulated in this way, leads only to circular reasoning. But to say that various Condon investigators had a lot of trouble, or logical trouble, as to say, to have rejected the ETI notion on logical grounds when presented in this manner, and have not attempted to reject it on empirical grounds. Stage 3. This, then, is the stage where we have for inspection at least population C and those reports from population B, which after further debate may be transferred to C. It must be remembered that the residue of reports at this stage only have a commonality of still being unexplained. That they may have descriptive identity or class definition has yet to be demonstrated and argued, not assumed. Descriptive identity is not to be understood as explanatory identity. A null set could still have properties. We can make classes of disease symptoms without knowing their causes. Nevertheless, stage 3 is a key link in our sequence, as failure to define the data at this point makes further analysis unamenable to systematic investigation. We need, therefore, to give considerable thought to it. The problem is to extract information from the reports, irrespective as to whether a physical, psychological, or sociological type of explanation is to be found. Now, information, in the technical sense, is reduced by the presence of equivocation and by the presence of noise. We need to apply these concepts of information theory to the case in hand. In doing so, I'm concerned only with a major source of data, that is to say, human testimony. The same principles must apply to other sources, such as information from radar and automatic instruments, but these contain different technical factors, and others, no doubt, in the symposium would be concerned with them. Now, class definitions have been attempted previously by NICAP and by Valley. Both are mainly based on the principle of dividing the descriptions into the main variables or attributes of shape, size, color, kinematics, etc., on the one hand, and by witness reliability on the other hand. Valley, in particular, is sensitive to some aspects of the noise factor, distinguishing his types to show resemblance or lack of resemblance to interfering irrelevant stimuli such as satellites, meteors, etc. At the outset, it should be obvious that the data we are inspecting and analyzing is that of the report of the witness or witnesses. As MacDonald has shown, secondary elaborations, such as newspaper accounts, which have their own motivation, for example, the interest of their readers, are often untrustworthy. Reduction of noise must include this factor. Also, there is the noise factor of time delay in reporting the event. Dr. Hall has covered other aspects of witness reliability. On the whole, noise factors appear to be well appreciated in this field. Equivocation factors are not immediately obvious as having been fully appreciated. Before we are confident of assigning percentages to attributes of shape, size, and so on, and basing explanations on them, we should appreciate that descriptions are peculiarly open to assumptive context. Shepard understands this, and his remarks in that congressional report refer to fresh methods of information retrieval, a very useful suggestion which means starting anew. We may have to do that, of course. Wertheimer undoubtedly appreciates this, but his short chapter in the Condon report concludes only that there is room for error. We need to find a method of reducing equivocation without going to the extreme of throwing up our hands in horror at the fallibility of human testimony, thereby invoking the complaint of Dr. MacDonald that the psychologist's, quote, puristic insistence on the miserable observing equipment with which the human species is cursed makes me wonder how they dare cross a busy traffic intersection, end of quote. I'd like to meet Dr. MacDonald after this one. Now, equivocation can be regarded as information which the organism cannot discriminate reliably, and is the very heart of our difficulty in definition. When a witness reports he has seen for a short time a disc-shaped large object hovering 100 feet away from him at treetop level, what credibility can be placed on the descriptive attributes of disc-shaped, large, 100 feet, hovering, and treetop level? There is little doubt the difficulties are formidable. Most people are unused to angular estimation. Most people tend to express themselves in thing language or object language and not process language. Many reports just do not give the basic information necessary to judge the relative accuracy of estimates of size, shape, distance, etc. Perceptual cues that may or may not have been present to the witness are often not noted in the reports. We're often not told what visual angle the observer made his observation from, what degree of illumination was present, what frame of reference was used. We do not know whether the witness has some implicit assumptions as to shape and size of UFOs, which would be very significant. The list might be multiplied. There are only two ways of adjusting to this state of affairs, other than planning anew the entire retrieval procedure of reporting these phenomena. The first would be, and heaven forbid it anybody really does it, first would be to go painstakingly through existing reports, noting what aspects of what reports can be relatively relied on. We can note whether the object was seen against a background which contains what's being called a microstructure, or against a kind of background of the sky which contains film color. This is a basic datum in perception, as judgment of distance and hence size depend on it. We can note whether the phenomenon was observed from directly above or below, or viewed obliquely, and how this correlates with the reported shape. We can ask whether there are quite different reports of movements of the phenomena when the witness is relatively stationary, as against when he is moving, as in an airplane or automobile, or alternatively, whether they're very much the same. Or again, as regards movement, whether the reported motion was seen against a fixed background or against a possible moving background, as a cloud. Such and further probing the present data could be made and would constitute some kind of check, however rough. The second way is to examine the data for what might be called latent descriptions. By latent descriptions is meant a relationship between attributes which emerge as a statistical invariant across the mass of reports. This requires going beyond the case-by-case approach and necessitates the cross-correlation of a number of reports on a statistical basis. Nightcap's linkage of reported motion and color is a step in this direction, as is Valley's analysis of the estimated size of objects to a distance from the observer. But the analysis needs to be done on a far larger scale and has only been tentatively attempted hitherto. Unfortunately, it appears that the mass of data had not even been marshaled into the form in which this can be done. Project Blue Book, Special Report number 14 in 55, made a study in which the data up to 52 were converted into IBM punch card form. The analysis, however, consisted of nominal classifications of attributes and geographical and time distributions, plus single attribute comparison with known phenomena. This has some value, but it doesn't go to the extent which I really would like to see. Unfortunately, one's learned that the whole card deck was thrown away. Hynek reveals in a letter reported by Markovitz in Physics and Metaphysics of these things that the Air Force does not have the material in machine-readable form. A man called D.J. Pearson, who I corresponded with, who was then at the Centre for Computing and Automation in Imperial College London, did perform a time series analysis of 1,500 British sightings, and he was prepared to construct a master program using the University of Colorado's project data when communication with the project staff broke down. Someone got dismissed apparently, and it all flopped. After the man in Dr. Saunders left the project, the data wasn't allowed to be released apparently to Pearson, so he tells me. I myself have in process an analysis taken from Olson's reference for outstanding UFO sighting reports. I took this document as a basis for analysis as it contains more information than most catalogues to justify coding and subsequent transfer to computer analysis. Also, as Olson himself states, quote, the criterion for including a specific sighting report in this reference is that it be so clear-cut, detailed, unambiguous, and unconventional that rational misinterpretation of natural or man-made phenomena is obviously impossible. Each acceptable report can have at most only three possible explanations. It is due to a hoax, a hallucination, or a real observation of an unusual phenomenon, unquote. Furthermore, Olson provides a reliability index based on the number and kind of witnesses, the experience and attitude of their interviewers, and the intermediate source of the report when it is unavailable directly. The study is very much of my study is very much of a pilot attempt, and one would need far more than the 160 cases which Olson has collected. Unfortunately, at the moment of talking, coding has been so slow that only about 2/3 of the set has been completed as yet. In order anyhow to have something to report on for this meeting, I can quote reports on a few points from 102 cases. At the outset, it's clear that even with Olson's fuller content, sufficient retrieval of desired information is lacking. One is struck with the frequency of no information that crops up in the analysis. What I'm doing is coding some 50 or so categories based on A, the characteristics of the witness or witnesses reporting the event, B, the conditions of the sighting, and C, the nature of the event reported. I've already hit some coding snags. My coders apparently have met difficulty with the linguistic habits of citers, especially with that related to a shape, the things like dumbbells and buns and doorknobs and things, which don't fit into any neat category scheme. We're at present trying to work out these abstractions. Anyhow, let me present with some very bad slides. There's no money these days from the National Science Foundation. I've had to rely on my students. And we've got some very bad slides, I'm afraid, which I may have to show out. Could I have the first one, please? I hope you can see that. Can people not see that at the back there? Is it that bad? It is that bad, I'm sorry. This is really breaking down his reliability scale. It runs from 0.1, being low reliability, to 0.9, against the main sources of the information. You'll note that it's broken into low and high, low being defined between 0.1 to 0.4, high to 0.5 to 0.9. And you notice that the U.S. Air Force at the top there has all of its cases in the higher reliability, whereas others are mostly between both groups, with the exception of a gentleman called Michel, who has 27 cases in the low reliability and 1 in the high. I hope he's not here when he sees this. It is low there. Of course, all these reports are somewhat even higher than the most reports due to the characteristics which Olson has selected them from. Next one, please. Maybe you can see that a bit better. Remember that these are reports in the Condon report and in the Gallup study 966. Dr. Lee, in a Condon report, found no difference in age or sex for citers. The difference here, of course unadjusted for ratios of sex and age, is probably due to the fact that these are reports and not opinion survey data. Next one, please. Oh, yes. These are the occupations. I think probably that's fairly legible. Next one, please. That's not so well written. This is the date and time of reports. You'll notice that there is a peak period, as it were, from 6 p.m. to 10 p.m., in which there are 33% of the sightings. This agrees both with Valley's analysis in Challenge for Science, which is type 1 and type 3, and with special report number 14. Remember, this is very much a function of when people might be able to see things and when they're out. And notice, of course, the summer frequency, July to December. Now remember, again, as I said before, that Olson's document is a very highly selected one, and this kind of analysis may not hold up if you took, let us say, all the 10,000 or whatever there are with the Air Force. Here's this with the really puzzling phenomena. Next one, please. This is, to my mind, quite an interesting analysis because the straight line is from Valley's analysis in his Challenge to Science of the duration of sightings, and the dotted line is from the Olson document. There seems to be a fit here. It might be due, of course, to the fact that the same population is being analyzed. Valley mentions only that his data is French and American. Olson's selections would include these, of course, but his coverage embraces other parts of the world. What I've been able to get from Davidson's edition of the Air Force Project Blue Book Special Report 14 shows wider class intervals for duration, ranging in various seconds or seconds to the interval 1 to 5 minutes, 6 to 30 minutes, and then over 30. If drawn to this graph, it will show a gradually descending straight line from left to right. Thus, I cannot tell from this whether the particular interval around 10 minutes shows a peak or not. Next one, please. This is a very bad slide, I'm afraid. This is the color analysis from three groups, from NICAP, from the Air Force Project number 14, and from my Olson analysis, breaking them down into percentages of what different colors were seen. The next slide actually will show the correlation between these, showing that all these significant rank correlations, by the way, that there seems to be a degree of association between the reported colors. And I think these three samples, the NICAP, the US Air Force, and the Olson, somewhat overlap, but not exclusively. Right, next one, please. This is a relationship between height and size. It would appear that the tendency for larger objects that are defined as being over 50 feet has been seen when they observed judged to be over 300 feet. And the inverse is smaller. This is significant using the elementary chi-square test. This, of course, may just be due to a factor of perception. One shouldn't necessarily conclude that there are A, real objects, or B, if there are, that they're of this side. But there is this tendency that comes out of the analysis. Next one, please. This breaks down the reported motion. They're about split halfway on a very small sample, of course. Remember, when I've taken this from 102 cases, but the information just isn't there in the remainder, so one ends up with n equals 39. There seem to be more cases of acceleration than deceleration, but if you take those two together, it goes half and half to whether the thing is judged to be doing constant or change. Next one, please. This is the internal motion of the UFO, seeing what kind of things it's meant to be doing, whether it's spinning or fluttering or jittering, as I don't know quite really clear what fluttering or jittering is, as the term is used, but one gets the impression that something like a leaf trembling or something like that. Whereas 42% have reported from a very small n, you'll notice, n equals 24, that, let's say less than 12, that there is a spin there. Next one, please. This is the thickness-diameter ratio, and I don't think it's very revealing, but we just threw it into the name. and then the last one, this. Here, the computer analyzed the direction in which the UFO was traveling when first seen, and against where it disappeared too. And it does seem to be, if you look up that diagonal there, a tendency for the things to go away in the direction in which they were first seen. Of course, I haven't pulled out these cases yet and have time to see whether they are of short duration, because if they're all of short duration, that's easy to explain. The thing really wasn't long enough to be observed, to see much change anyhow. But if they're not, certain interpretations might be put in it. All right, please, and lights. Of course, interpretations of such relationships, if they prove to exist, is another matter, and that brings us to the last stage. Having arranged and refined the data, the stage is now relatively clear for hypotheses to be brought to bear on them. Our sequence of stages is not meant to insinuate an inductive approach in which the systematic refinement of data astonishingly reveals an explanation. After all, a hypothesis might demand a datum which no one has yet reported or anyone thought of asking for, and may include other factors than descriptions. The intention here is only to seek a confrontation of data and hypotheses, a feature which is somewhat lacking in this field. This is partly due to the dirty condition of the data, Dr. Hartman calls it atrocious, partly to the dominance of a priori assumptions. Indeed, assumptions have tended to be voiced in ways which encourage ignoring the data rather than their correct role of indicating the required threshold of evidence. Furthermore, little thought has been given to how certain hypotheses could, in principle, be tested. This is crucially true of the extraterrestrial hypothesis. I've already suggested that proof of this cannot rest merely on the bizarre nature of the reports. Apart from tracking such an object, the only approach that seems at all possible is to posit a model embodying aerodynamic and engineering properties that are then matched against the observed data as reported. This approach has been tried by some, yet there are logical hazards even here. One might say that there is a higher and a lower limit within which such a model can operate. The higher limit is bounded by postulating magical mechanisms with which anything is possible, and therefore nothing. The lower limit is bounded by the fact that if the model makes physical sense, then presumably it has the status of an invention, and we could build such. It would be truly ironic if a flying saucer was constructed on the basis of clues that were wholly the product of a 20th century myth. Unfortunately, there is a property of hypotheses between the extremes of extraterrestrial machines and misinterpretations of known phenomena. There is the possibility that a real unknown phenomenon is being reported in language that is misleading. Class's ball lightning hypothesis, while it may not adequately explain the sightings as reported, does at least have the merit of exploring other possibilities. Let me conclude with an anecdote, really, which I think emphasizes the point that Dr. Hall made. It's an experience related to me by a friend that happened to him and a colleague back in 1952. These two were fishing in a reservoir in Colorado at dawn when they heard what sounded to them like a flock of geese batting on water, just the other side of a strip of land some 20 yards away from them. What they saw was what looked like an aluminum curve-shaped doorknob about 2 by 2 feet sticking above water. The object moved away from them at a speed which just about 100 miles an hour in a wheeling S-shaped motion and then was lost to sight. My friend never publicly reported this artifact, nor indeed has he told more than a very few friends. Now, I don't want to present this as the case of an unidentified underwater object. As for all I know, the U.S. Navy submarine department may have gone into that Antarctic at the time with curious periscopes and new forms of underwater kinematics. The point of the story lies in the very first words that our friend said to his colleague after they recovered from the surprise. Guy, you know there's no need to tell anybody what we saw because they won't believe it. Such a comment says more about our culture than it does about UFOs.